Earthquake is an unforeseen disaster that offers destruction of property and loss of life. Thus, we need someone to tell us the story about it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ryan Najmi Ahmad Shad. My metric number is 1915291.
I am Muhammad Hasri bin Hasbullah 1816555.
I am Kashful Hakim bin Shaharuddin, matrix number 1811281.
We will present about earthquake-induced structural vibration. For background, in the case of earthquake modeling, a differential equation system can be used to describe the oscillation of building that is subjected to the seismic forces. Okay, our objective for this research is to find the lateral movement of one-story building by considering the external forces that apply on the building.
Okay, now let's get to know about mathematical formulation for this topic. Here is the mathematical model for one-story structure, including the effect of the structure towards the external force, which is earthquake. Do you want to know how we get it? It's okay, I will explain it to you guys. First, we want to consider the effect of the structure toward the earthquake. Then, we divide it by two components, which are vertical and horizontal displacement. We took the formula of Hooke's law and Newton's second law to represent the displacement variable respectively. By combining both formulas, an expression for the total force can be derived. We modified it a bit, then this variable represents the magnitude of the earthquake force. We assume the earthquake to be harmonic, and lastly, boom, we got it. Okay, for the specific terms, x double prime is for horizontal displacement, k is for stiffness of the structure, m is the mass of the structure, x is the vertical displacement, omega squared is for frequency of the earthquake, f naught is the amplitude of the earthquake, and t is the earthquake duration in second.
So for the manual solution, as given the initial condition, our problem is non-homogeneous equation. So we will use this equation, which is vector z equal to vector z homogeneous plus vector z partial solution. So for the solving vector z homogeneous, we take the homogeneous part of the equation and then we derive it until we get all of this information. Thus, we use the same method to find eigenvector, eigenvalue, and we put in order until we get into this general solution for the homogeneous equation, which is vector z homogeneous, and this is the vector z, and then the constant. And then using the same order, we find constant, and we use the initial condition. Thus, we get 0. Hence, it make our homogeneous equation 0. After that, we find a particular solution. We use the variation of parameter method. So this is the formula, and we just put everything into order, and then finally we get into this. We get this answer. So this is the vector z partial solution, and then for the general solution, we put it back into the order. So since partial vector z homogeneous solution is 0. Hence, we get the vector z equal to vector z partial solution. So, therefore, this is the answer. Computer-aided solution, we use simple coding. We use Python, importing SciPy, and we use the differentiation and get the vector zh, and then we get the vector zp, which is we just put it out the yt, and then for the graph, we just print out yt, which is we get the displacement. The graph of the earthquake induced on one-story building vibration, which is this is the displacement that happened on the building. So it is fluctuation, and the upper and lower boundary is increasing, as we can see. In this 5 seconds, we see that the top is 15,000 meters and the lowest is negative 15,000 meters. So as we know, it is unlogical, but because this model we take the undampened one, so that's why the result is very high. So I think that's all. Thank you.